Welcome back to part 4 of pharmacotherapy for Parkinson's disease. So the next research article is Microglial Inhibiting Activity of Parkinson's Disease Drug Amantadine. So this study examines the effects of the drug amantadine on Parkinson's disease. The mechanism of action for this drug is Parkinson's disease therapeutic. The mechanism of action for this therapeutic drug as Parkinson's disease therapeutic is not known, but it is believed to inhibit microglial activation and neuroinflammation that is believed to play a role in the progression of the disease. So specifically, they used cultured microglial cells to examine the anti-inflammatory properties of the drug. Their results showed that the amantadine did have these properties and that they inhibited the microglial cells from inflaming and thereby reducing any kind of neurotoxic or neuroinflammation effects. Furthermore, they also did provide a simple mechanism for the actual action of this drug and why it works at the molecular levels. And essentially it had to do with the regulation of the mRNA, which codes for proteins. So, overall, the drug inhibits the inflammatory response in the microglial and reduces the neurotoxic effects that are caused by the inflammation. So, I included this article because it's a good example of the future prospects that Parkinson's disease, in terms of drug therapy, that it has. Like amantadine, it has some future prospects. The next research article was D13N-butylphalidide, a natural antioxidant, protects dopamine neurons in routine models for Parkinson's disease. So, as we mentioned earlier, there's the free radical hypothesis, and according to this hypothesis, it is the reactive radical species that can be attributed to the neurodegenerative effects of Parkinson's disease, and this article examines the effects of the natural antioxidant NBP as a protective effect in Parkinson's patients. So in their experiment, they found that this antioxidant enhances the viability against toxicity, as well as it reduces apoptosis, which is death, and reactive oxidative species and mitochondrial membrane potential reduction. So it was also shown to rescue dopaminergic neurons by 30%. So essentially, the benefit of this drug is that it reduces oxidative stress that can attribute to Parkinson's disease's neurodegenerative effects. So in conclusion, we examine the therapeutic effects, the therapeutic efficacy of current drugs for Parkinson's disease, as well as we covered some future prospects such as antioxidants and amantadine. The key point, though, is that the efficacy of the drug is dependent on a couple of factors, such as the patient's metabolism. Drugs are very specific to people, so you have to get the right combination of drugs as well as the dosage. You have to also consider the stage of Parkinson's disease, whether it's early or if it's late Parkinson's disease. And you also have to consider the dosage amount because, as I said, every patient is different. As well, you want to consider the difference between monotherapy or adjunction therapy or conjunction therapy, because there is differences and there is either enhancements or decreases in efficacy. So, with the increasing knowledge of the mechanism of action for drugs such as with amantadine and antioxidants, the increase in knowledge of the cause of Parkinson's disease, such as the free radical hypothesis, the possibility for a highly efficient drug that reduces the neurodegenerative effects may be in the future. So we may be approaching the possibility possibility that we might eradicate the neurodegenerative effects as well as the motor symptoms that is associated with Parkinson's disease. Alright, and here's my references. And thank you.